So today I am going to perform a very beautiful experiment, that is I want to measure the surface tension of water and soap solution using Tate's law. Tate's law. Here I will use a syringe as it is seen here, right? So first of all, let me briefly talk about its theory. So suppose when syringe is filled with water and we drop, say if I slowly and steadily press it, then drops will fall down from here like this, and see the shape of the drop, right? So that means this is the syringe, right? And this is its tubular part from which what will come out. So now what will happen, this is the diameter, internal diameter of this syringe, means it is the internal diameter of this part, right? What which I am talking about here, right? This is the internal diameter. So what will happen when it comes down slowly and steadily? The weight of this drop is balanced by the force due to surface tension, because surface tension will act on the drop in upward direction. This is basically Tate's law. So that means this force means force due to surface tension is balanced by weight of the drop. This is the experiment, right? So what is the force due to surface tension? It is pi d tau. Here this d is the diameter, this internal diameter, and tau is the surface tension, and this pi d basically it represents the circumference of the tube, circumference of this part. This is the circumference. This circumference will remain as it is, as this one. So when this drop will fell down, that means this drop's weight is balanced by this one, right? So that means we will use the formula that pi dc is equal to pi d tau is equal to mg. Pi d represents the circumference of this region, right? Now what I will do, I will calculate from here this value comes out to be mg over pi d. So that means m is the mass and g is the gravity, acceleration due to gravity, and pi is the simple pi, and d is this diameter of this one, right? So the syringe which I have taken the syringe whose diameter is 2 mm. I carefully measured it, and the value of g will be 989 per centimeter square. So let us perform this experiment. First of all, what I did, I filled this syringe with water. I think it's clearly visible, and I have taken a syringe of 5 ml, and its internal diameter will be 2 mm. Now I have used this weighing machine to weight it, right? This is the weighing machine, so I am using it. So it is set at 0, and I placed it on this, right? So when I placed on it, it weights it weights 9.12. It is its mass in gram, it is 9.12. And what I did, I carefully dropped 20 drops from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20, and then I weight it again. after the removal of the 20 drops. Now its weight is 8.33. 8.33 is its weight now, right? Now take its difference, and then I will calculate mass, and then I can calculate the surface tension of this liquid, right? So, and here I am taking first of all the plain water. So let me do, and I will repeat this experiment 4 times, and then I will take the average of this. So let me do all these observations in this way, and after completing this table I will show you that what we are observing. So I repeated the experiment time and again, and it seems that there is a lot of difference, so I omitted this first reading, and I have taken in place of that this reading, and this is the mass of each drop. Then I have estimated the surface tension in unit dyne per centimeter, and these are the values after doing little calculation. And if I take the average of these values, then average comes out to be 66.128 dyne per centimeter. And let us have a look at the actual value. Actual value I have taken from 71.03 dyne per centimeter at 30 degrees centigrade. And this I have taken from the Physics Education journal. This is the reference of this journal. And right now the temperature, room temperature in which I am performing the experiment, it is 30 degrees centigrade, right? So, and if I estimate the error, then estimate from when I estimated the error from this experiment, the error comes out to be 6.9% with respect to this value, right? So our result is more closer to the actual value, and the difference from the actual value may be because of the internal diameter of this tube is not more closely or more accurately measured, and it may be because of that. Thus, using this syringe method or Tate's law, we can beautifully estimate the surface tension of any liquid. Now, in the second part of this, I will perform the same experiment with soap solution of different concentrations. So let me do that experiment now for you. I have made a 5% solution, soap solution, right? And I will repeat the same experiment with this soap solution, right? And let us see what will happen to this experiment. So this I filled with a 5% soap solution. I put it on the weighing machine, and its weight will be 8.39. Its weight will be 8.39. Let me write down its value, 8.39 gram, and rest of the parameters will remain the same. And let us count the number. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. And let us weight it again. So its weight will be now 7.96. Its weight will be 7.96. And I will repeat this experiment with 10% concentration, then 20% concentration. So I will perform this experiment and then complete this observation, and let us see what will happen to the surface tension with the concentration of the soap solution, right? So I have performed the experiment with 5% concentrated solution of soap solution, and these are the readings which I am getting, and the average value comes out to be 34.83 dyne per centimeter. And when concentration is further increased to 5% to 10%, then its surface tension is also kept on decreasing, and similarly for the 20% it comes out to 29.15. Thus the surface tension of soap solution is smaller than the pure water, means in soap solution surface tension decreases, and with the increase in concentration we observed that the concentration of the the surface tension of the liquid gets decreased, right? So this is all about this a very beautiful experiment which I performed. So thanks for watching this experiment.